Welcome back to another episode of gamma function. In this episode, I am going to solve a very unique problem. Integration 0 to 1, and this given integration problem we have to convert into in terms of gamma function. So before this video, I had already solved a few problems based upon gamma function from episode 1 to episode 5. This is episode 6. If you have not gone through first episode to fifth episode, please go to them. I will provide the link in my description box. So let us start solving this question. To solve this question, we are going to use first converting the given function into standard beta function form, then converting beta to gamma by using relation between beta and gamma function. So here are the two steps required. In the step 1, we have to convert into standard beta function. Then second step, beta to gamma function. So let I equals to integration 0 to 1 x raised to m 1 minus x raised to n whole raised to p with respect to x. Now you have to always put your attention inside the bracket. Now in standard form, inside the bracket there is a single variable. It is just a single variable. There is no x raised to m, there is no x raised to half, there is no m upon n form. So it is a single variable without any additional mathematical form. But in given problem there is x raised to n. So we have to convert x raised to n in single identity, such as in standard form. In standard form there is 1 minus x, but in given question it is not 1 minus x, it is 1 minus x raised to n. So we have to convert this x raised to n into single form, such as in standard form. Therefore let x raised to n equals to t. First we will use x raised to n equals to t, and later on x is replaced by t raised to 1 upon n. Now x raised to n equals to t, we do differentiating with respect to t. So differentiation of x raised to n with respect to t equals to differentiation of t with respect to t. We get here n x raised to n minus 1 multiplied by dx by dt equals to 1. This can be written as n x raised to n multiplied by x raised to minus 1 dx by dt equals to 1. So this can be written as n x raised to n x raised to minus 1 dx by dt equals to 1. And in place of x raised to n, we can write t, because we already made a supposition that x raised to n equals to t. So we got here 1 upon x dx equals to 1 upon nt dt. Now in given problem, multiplying and dividing by x, this becomes 0 to 1 x raised to m plus 1 divided by x 1 minus x raised to n whole raised to p with respect to x. So I can be written as x raised to m plus 1 1 minus x raised to n whole raised to p, of course integration 0 to 1, and 1 upon x dx. Before proceeding further, let us change the limits of integration. So as for x equals to 0 implies t equals to 0 raised to n equals to 0. Therefore lower limit for t is 0. Then we have x equals to 1 implies t equals to 1 raised to n equals to 1. Therefore as x tends to 1, then t also tends to 1. So limits for t are remaining the same, that is 0 to 1. Therefore I equals to 0 to 1. Now converting the given integration problem in terms of t. So for t the limits are remaining same, 0 to 1. and in place of x equals to t raised to 1 upon n, so t raised to 1 upon n whole raised to m plus 1 minus, and x raised to n equals to t we are already having, so here in place of x raised to n let us write down the t whole raised to p, and in place of 1 upon x dx replacing it by 1 upon nt dt. After that this n taken common, so 1 upon n 0 to 1 integration 0 to 1, and here is the 1 upon t written here, so this becomes I equals to 1 upon n integration 0 to 1, and this becomes t raised to m plus 1 whole upon 1 minus 1 minus t raised to p dt. Now in second bracket the power is n minus 1, but in our problem there is no minus, there is only p. To create minus 1, what I am doing here, I am adding 1 and subtracting 1, so it becomes p plus 1. Now comparing with the standard beta function, in place of this m we have m plus 1 divided by n, comparing respective terms, and in place of this n there is p plus 1, and result is beta mn. So result of our question is in place of m there is m plus 1 upon n, therefore it becomes beta m plus 1 divided by n, comma, and in place of n you can write down p plus 1. So result of our integration is beta m plus 1 divided by n, comma, p plus 1, and out of integration there is 1 upon n, so it becomes 1 upon n multiplied by beta m plus 1 upon n, comma, p plus 1. But we have to convert this in terms of gamma. So how to do that? We know that relation between beta and gamma, that is beta m n equals to gamma m gamma n divided by gamma m plus n. Therefore 1 upon n, beta of this one is equals to 1 upon n, and in place of m there is gamma m plus 1 divided by n, and in place of n gamma p plus 1 divided by addition of both, that is m plus 1 upon n plus p plus 1. Therefore integration 0 to 1 x raised to m 1 minus x raised to n p equals to 1 upon n, and beta form equals to 1 upon n gamma form. In this way we have converted beta to gamma and we obtain integration result as well as. How was the presentation? If you liked it, please like, share and write down some comments in comment box. Meet you again with next question, next problem on gamma function. Till then, wish you good luck, all the best.